Hello, 8th grade math. We're going to be doing lesson 6.6, problem solving and inequalities. Please have your books open to page 324. It will make a lot more sense if you follow along in your book because there's some word problems that are going to show up right away that we're going to use as some examples. So let's dive in. A lot of times when I'm thinking about when I'm going to use inequalities in the real world, it kind of shows up in situations like this. Maybe not exactly this situation, but I use inequalities a lot when I'm determining when I'm going to have good value, a good bang for my buck on certain deals that might come our way. And we'll see an example right here in example 1. The story problem that goes with it refers to season tickets. I'm going to read straight from the book. It says, individual tickets for a college hockey game cost $8 each, plus a one-time transaction fee of $5. You can buy a season ticket for $99. How many games would you have to attend so that buying a season ticket is a better value than buying individual tickets? So to solve the problem there, we're going to write and solve an inequality, and we're going to let x represent how many games we're going to go to. So basically what we've got going on here is we've got the price of a single ticket and we're going to multiply that by the number of games. Now this number of games is going to be the same on both sides. Actually, it's just going to be on this side, I guess. This is all one piece. So this is going to kind of be the determining factor. This is our variable piece. It changes depending on how many games we're counting for. So the price of a single ticket times the number of games. But remember, it also said there's a one-time transaction fee of $5. So I'm going to write transaction fee, or I'm just going to write trans fee because I'm already running out of room. So on top of the price of the tickets, the price of the single ticket times the number of games, I also have to add that transaction fee, but I only have to do that one time. I don't have to do that for every single game. So I'm only going to be doing that one time. I want to know at what point is this going to be greater than the cost of the season tickets or the price of the season tickets. So in other words, I'm trying to figure out if I go to 5 games, is it worth the season ticket? If I go to 10 games, at what point is it that this number, or I should say this number, all of this combined, this side of the inequality, I want to know when is this more expensive than getting a season ticket pass. Okay, so that's what I'm doing here. These are my pieces here. I'm going to see what I can fill in to solve this scenario. So now the next thing we're going to do is I guess I just got to fill in the pieces that I know. So for example, do I know the price of a single ticket? I do. The book tells me that it's $8. Do I know the number of games? I don't, but the book tells me to let x represent the number of games. So that's going to be my variable. I'm going to see what I'm going to be able to do with that variable to figure out how many games is it going to take to make this side more expensive. On top of that, I have to add that $5 transaction fee. Okay? Now, I've got multiplication and addition. Therefore, I don't have an opportunity to use the commutative property. So I'm not going to be able to do that to solve this. But I want to know when this is all going to be greater than the price of the season tickets. Do I know that? It does give me the price of the season tickets. I believe it was $99. So in other words, I want to know when it's going to be above $99, probably $100. Okay, so let's take a look. $8 times x. I'm going to write that a little bit differently. This is not necessarily the neatest way to write it, so I'm going to rewrite my problem. I'm going to change lines. I'm going to change colors. So here we go. I'm going to do 8 times x plus 5 is greater than 99. This is, I went from having a verbal model to a variable inequality. So now this is what I've got to solve. I've got to solve this inequality for x. In other words, I want to get x all by itself. And by doing that, I'm going to figure out how many games it's going to be to cancel out the cost or to be a better deal to get the season tickets instead of the individual tickets. So let's see here. I've got a couple things happening to x. The first one is multiplication, and the second one is addition. Now, remember, we're going to kind of try to use reverse PEMDAS, for lack of a better term. And so reverse PEMDAS would say, instead of doing the multiplication first, because I can't undo that right away, I'm going to get rid of my addition. So the inverse operation of adding 5 is subtracting 5, but I've got to do that to both sides of my inequality. Otherwise, I've knocked everything out of whack. So I've got to keep everything balanced to where it was. Plus 5 minus 5, that cancels each other out. Over here I have 8x, which drops down. 8x is going to be greater than, well, if I take 5 away from my season ticket price, it would be $94. So now I got to figure out, when is 8x the greater number than 94? So now to solve for x in this scenario, I'm going to divide both sides by 8, because x is being multiplied by 8. So the inverse of multiplying by 8 is dividing by 8. These cancel out. The 8's cancel out, leaving me with the x on the left. It's a greater than sign because I divided by a positive integer. So my sign did not switch. Remember, if we divide by a negative, my sign is going to switch. And then I've got to do 94 divided by 8. And 94 divided by 8 is going to be, well, let's see here. If I pull out my calculator, oh, I got some numbers on there already. 94 divided by 8, and it's going to give us a decimal number, 11.75. So x has to be greater than 11.75. So my question again was, how many games does it take to make it worth the season ticket price? If I go to 11 games, 11 is not greater than 11.75. Obviously, I can't go to 11.75, or I could, but I'm still going to have to pay for the full price of that last game. Obviously, if I bump that up, though, I will be greater than 11.75. So let's just like say, in other words, what I'm saying is I can't put 11 in for x. That would make an untrue statement. So 11 is greater than 11.75. That is false. No, can't do it. But I could put 12 is greater than 11.75. So my answer is that it would take 12 games before I would have to go to 12 games before the season ticket price was the better deal. And so there we have it. So I've gone from a verbal model to a variable inequality. I did my inverse operations, leaving me with x is greater than 11.75. In other words, 12 games would be what it would take. Okay? Some other things to think about in your book on page 324 that I want you to just kind of want to point out to you. Please turn to it. It says, when at the bottom of page 324, when writing inequalities, the following common sentences indicate 4 types of inequalities. So take a look at that grid there. When we have A is less than B, there's a couple ways we could say that. We could say A is less than B, or we could say A is fewer than B. And it's important to kind of point that out because in this lesson, we're going to see both of those kinds of words pop up. So A is fewer than B, A is less than B. Either one of those would work. If I kind of divide this up similar to how they have it in the grid, the next box, they have A is greater than B. And again, that's the term that we are probably more comfortable with. A is greater than. But you could also say A is more than B. And then down on the bottom, they have the same things, only we've got the lines underneath, which means that it can also be equal to. There's a few different ways that we could read this. We could say less than or equal to. We could say that A is at most. If you think about it, the most that A could be is the most that A could be equal to is the same thing that B is equal to. It would have to be either less than or at most equal to it. Or you could say A is no more than B. Just kind of two different ways of saying the same thing, but this is just kind of vocabulary that's going to pop up. A is less than B, A is fewer than B, greater than B, A is more than B, and down here we have less than or equal to, is at most, is no more, and you might be able to guess what we're going to do over here. Oops, I already goofed that up. A is greater than or equal to. And then what we'll do is we'll kind of just do the opposite of this. Instead of is at most, we're going to say it is at least. At the very least, A is going to be equal to B. But likely it's going to be greater than B. Or we would say is no less than. It is no less than B. Okay, so these are all different ways of kind of saying all the same thing. I really encourage you to kind of bookmark that. That's on page 324 in your book. Don't hesitate to go back to that during your homework. Example 2, it says translating verbal sentences. And that's why, because that's what we're trying to do right here. So that's why we took the time to take a look at this. Don't hesitate to look back at that chart, that table as we're doing this. Example 2, I'm asked to write the sentence as an inequality. And in example 2, for example, example 2a, I should say, I am given 6 times the difference. Remember, difference implies that there is subtraction going on, and I'm going to subtract the next 2 things that it tells me of a number and 3. I'm running out of room. Is more than 24. Okay, so what we're going to do is we're going to try to pick apart this sentence here and see what we can come up with. So obviously there are some easier things to pick apart and there's some tougher things to pick apart. So for example, an easy thing to pick apart is 6. 6 is going to be 6. We also know that times is going to be multiplication. But I'm not exactly sure what I'm going to multiply. 6 times what? Well, the thing I'm going to multiply is the difference. Remember, we said that there was going to be a multiplication problem, or a subtraction in here. So I'm going to multiply 6 times the difference. Now, in order to multiply 6 times the difference, remember, order of operations would tell me that I'd have to multiply this times whatever comes here before I do the subtraction. So in order to get that difference subtracted first, because I got to multiply 6 times the difference, I need to put it in parentheses. And what am I going to subtract? Well, that's going to be the next 2 things that come up. The next 2 things that pop up are a number and 3. I'm going to do it in that order. If I don't know what the number is, it's just telling me a number. That means that I have a variable. So I'm going to use x. And then the thing I'm taking away from x is 3. So far I have 6 times the difference of a number and 3 Now here we go back to this page. It says is more than 24. So is more than shows up over here with this symbol, with the greater than symbol. So 6 times the difference of a number and 3 is more than 24. And 24 is another easy one. So there we have it. Just by doing that like that, taking your time as you walk through it, pick apart every little piece that you can translate what the text is saying into math stuff, math inequalities, and that's what we need to do. Now I'm going to be asked to solve this, and in order to solve this, I've got to get rid of these parentheses. I can't do that with the parentheses there, so I'm going to have to use my distributive property to get rid of this multiplication if I can't get rid of the subtraction first. So I'm going to distribute 6 inside of here and multiply 6 times x. I'm going to multiply 6 times a negative 3. Remember that negative sign goes with, or that subtraction sign goes with the 3. So 6 times negative 3 is negative 18. And look at that, my negative 18 turns into a subtraction. 6x minus 18 is greater than 24. So, again, algebra is really easy. You get your letters to the left, your numbers to the right. Don't forget to switch your sign if you need to. So here we go. I want to swing all my numbers to the right. My letters, in other words, my variable terms are going to be on the left. That's going to be my first step at this point. So I'm going to add 18 to both sides to keep it in whack, to keep it balanced to where it was. On the left, I have negative 18 plus 18 canceling out, leaving me with 6x is greater than. And then on the right, 24 plus 18 is 42. Last but not least, my final inverse operation is going to be division, because multiplication is going on here. 6 times x, the inverse of multiplying by 6 is dividing by 6. And I have x is greater than. Remember, I don't switch my sign because I'm dividing by a positive, not a negative. If it were a negative, I would switch my sign. X is greater than 42 divided by 6. There's a flashcard problem. X is greater than 7. As simple as that. So this is a long process. I do know that this is a long process to go from all the way up here, all the way to down here. But take your time with it. Pick it apart piece by piece. Start with the easy stuff that you know. 6, 24. The difference means that there's going to be subtraction in there. Go back to this page and look for which phrase is used. That'll tell you what sign to use. All that fun stuff. There's a couple more examples like that in the book. I'm going to ask that you take a look at them. Example 2b says 9 more than 4 times the number is at least 30 plus 11 times the number. Wow, that sounds like a lot, but when you write it out, it actually makes a lot of sense. Take a look at how they break it down as well. I encourage you to actually, if you're struggling with this, my recommendation is this: write it out. If you can do it on one line, that's best. I wrapped around to 2 lines, but if you can get it all on one line and just drop down the stuff, change it from words into numbers and symbols, that's the way to do it. If you can write it down, it will help. You can underline stuff, cross it out, however you want to do it to help you kind of pick apart the things that you've done and the things you need to get to yet. In example 3, it says writing and solving an inequality. So this time what we're going to do is we're going to kind of go back to a similar situation to what we had at the beginning with the hockey tickets. We're going to be given a word problem, and we've got to kind of make some sense of that and put it into a verbal model before a verbal model. Again, verbal model meaning words. We're going to have to kind of put it into like a word model form before we translate it into numbers and symbols. So it says owning a business. You use the internet to sell mouse pads, and you pay a wholesaler $6 for each mouse pad. Then you sell the mouse pads for $10 each. You pay $21 per month for web page hosting. How many mouse pads should you sell each month to earn a profit? So let's think about this. I got to figure out how many mouse pads I've got to sell. So in order to do that, what I'm going to have to figure out is I'm going to have to figure out what my selling price is. And that's the piece that I do know, because I know that my selling price is $10. It gives me that information in the problem. But the next piece is the part that we're questioning. What is it? I want to know how many mouse pads I'm going to have to sell. So the selling price times the number of mouse pads. I need to know when this number is greater than all my costs. So let's take a look at my costs. Well, one of my costs is how much I pay the wholesaler. So the wholesale cost, or the wholesale price, times the number of mouse pads. Again, this number should be the same as the number over here. And I'm running out of room, but I'm going to have to add to that my web costs, or my web page cost. So here I have the wholesale cost times the number of mouse pads. This is the same number of mouse pads I'm trying to sell over here. I want to know the selling price is greater than the wholesale cost. How many do I have to sell, in other words, to cover my web costs? So let's take a look at this. We're going to fill in the pieces that we know. Again, it's as simple as that. Just start slow and fill in the pieces that I know. I know my selling price is $10. I don't know what my mouse pad, or the number of mouse pads I have to sell. That's what I'm trying to figure out. So I'm going to use a variable for that, and I'm going to use the letter M for mouse pads. I want to know when this, in other words, the money that I'm bringing in, is bigger than this, which is the money that I have going out of my business. This is the money going into my business, and I'm in the business of making money. I want to know when the money that I make is greater than the money that I spend. And so now, do I know the wholesale cost? I do. I believe it was, oops, I'm glad I checked, because I thought it was $4. It's actually $6 per mouse pad. I want to know how many mouse pads I have to buy and sell in order to get that. And then on top of that, I also have to add my web costs, which they tell me is a total of $21 per month. So right off the bat, I'm going to have $21 just out of my pocket. So this is a good start, but I would never really work a problem with like multiplication signs like this. Let's put my variables into kind of a coefficient form there. So 10 times m, 10m. 6 times m is 6m plus 21. And now what I'm going to do is, again, it always goes back to that phrase, letters to the left, numbers to the right. My numbers are already to the right, but my terms, my variable terms are still separated by that inequality symbol. So I'm going to have to use my inverse operations. Remember, this is a positive 6m, so my inverse of a positive 6m is a minus 6m. I'm going to subtract 6m's from both sides. If I have 10 m's over here and I take 4 of them away, if I have 10 m's over here and I take 6 of them away, I jumped the gun there. I gave the answer. I have 4 m's left. 4 m's is greater than, these guys cancel each other out. and the 21 just drops down, so 4m is greater than 21. Now, let's pull out my calculator again, and this time I have to divide both sides by 4. On the left, that's the easy part. M is greater than. On the right, 21 divided by 4. Now, I could probably do this without a calculator, but we'll do it. 21 divided by 4 is 5.25. So the number of mouse pads I sell has to be greater than 5.25. But obviously, I cannot sell 0.25 mouse pads. So my answer, I'm going to have to bump it up to the next whole number. I'm going to have to sell a total of at least at least 6 mouse pads. And I kind of answered that question wrong. Not wrong. I mean, yes, it is right. But the question that they stated was actually, how many mouse pads should you sell each month to earn a profit? You know what? I'm actually going to say that I said this right. I'm going to claim that the book actually did something wrong here. It says to earn a profit. To me, I would kind of read that as being at least, and that's how I did read it. So I said at least down there. I would make each of these greater than or equal to. So in other words, I could sell 6 mouse pads and be greater than 5.25, but I could also sell 7 mouse pads and be greater than or equal to 5.25. The truth of the matter is I cannot actually be equal to it, but that's how I would actually calculate business costs is using the at least formula. Business people always want to know where it is that they have to get to in order to break even. That's kind of the term that they use, is breaking even. All right, so I've got just a couple more things for you here. First of all, I'm going to give you your assignment. I'm going to put this back up here in just a moment, but I want you to do page 326, numbers 1 through 8 and 13 through 15. I want to just take a quick glance at numbers 13 through 15, and I'll bring our book over here so you can kind of see. The directions state, I just want to kind of reiterate what the directions are saying and how we can make some sense out of that. It says, tell whether it makes sense for the variable in red to have a value that is not a whole number. So for example, it didn't make sense for me to have 5.25 mouse pads. It would either have to be 5 or 6. And since it had to be greater than, I had to bump it up to 6. So for example, this shouldn't be too complicated, but let's think about ride tickets. The entrance fee plus the ride ticket price times the number of ride tickets. Can I buy a fraction of a ride ticket? Okay, that's kind of what it's asking. So you got to ask, does it make sense for this to be able to be a fraction or a decimal? Can I buy a fraction of a pound of ham? Or can I buy a fraction of a pound of ham? Can I buy a fraction of hot dogs? So that's kind of what I mean by that. So think about that when you're kind of making sense of that. Can I buy a fraction of those items? So once again, I'll put your homework numbers right up here again. Page 326, numbers 1 through 8 and 13 through 15. Thank you very much.